Hello and welcome back to my channel, as it were, and today we're going to be doing some roots of polynomials revision for further maths. That's further maths A-level. So, we're told a student awoke at the end of algebra class in time to hear the teacher say, and I give you a hint that the roots of the polynomial form an arithmetic progression. And looking at the board, the student only had time to copy out x to the 5, not plus, minus 5x to the 4 minus 35x to the 3 plus, and that's all he managed. And that was all he managed before the teacher erased the blackboard. He was able to find the roots anyway. So what are the roots? And that's the question we're going to be answering today. So, first of all, we know that this will have roots alpha, beta, gamma, delta, and phi, because I don't know how to write an epsilon. Or at least my epsilons look weird. So, and they form an arithmetic progression, so there is a common difference d between them. So, alpha will obviously be equal to alpha, beta will be alpha plus d, gamma will be alpha plus 2d, delta will be equal to alpha plus 3d, and phi will be equal to alpha plus 4d. I'm going to redraw that phi. And so, what we're going to do is we know that negative b over a, so this term, is equal to the sum of the roots, sigma alpha, the sum of the roots, which is just alpha plus beta, etc., 2 plus phi. And that will be equal to minus 5 in this case, or negative b over a, so it will just be equal to 5. Because that's negative 5 over 1, so negative 5 over 1, which is equal to 5. And that will be equal to the sum of all these things, which will be 5 alpha plus 10d, because 1 plus 2 plus 3 plus 4 is 10. And now we can simplify this. So we know that 5 is equal to 5 alpha plus 10d. I can take out a factor of 5 and say that 1 is equal to 1 is equal to alpha plus 2d, which actually is equal to gamma. But we found one of the roots, so that's progress. And we know that the sum of paired roots will be equal to minus 35 over the a term, which is just 1, so minus 35. So the sum of paired roots, sigma alpha beta, is alpha beta plus alpha gamma plus alpha delta, and so on until we get gamma delta, and so on again until we have our final terms, so delta phi. And we can factorize this. We can make this alpha times beta plus gamma plus delta plus phi plus beta times everything but alpha times gamma plus delta plus phi plus gamma times everything but alpha and beta, delta plus phi, plus delta times phi. And that will be equal to alpha, just stays as alpha, times by, so that will be 4 alphas and 10 d's. Plus, beta was alpha plus d, times 3 alphas plus 9 d's, because we're only missing the d here from our full set, plus alpha plus 2d times 2 alpha plus 7d plus alpha plus 3d times alpha plus 4d. And that will be all we have. So that comes out as 4 alpha squared plus 10 alpha d, fairly easy so far, plus 3 alpha squared plus 12 alpha d, that's just 3 alpha d here, and the 9d times alpha, plus 9d squared, plus 2 alpha squared plus 11 alpha d, and that's because 2d times 2 alpha is 4 alpha d, and alpha times 7, so 7 plus 4 is 11, plus 14d squared, and that will all add to make alpha squared, sorry, that won't all, and the next one is alpha squared plus 7 alpha d, that's just 3 plus 4, plus 12d squared. And that will all make, so 4 plus 3, 7, plus 2, 9, plus 1, 10 alpha squared, plus 22, 33, 40 alpha d, plus 9 plus 14 is 23, plus 12 is 35, d squared. And that will all be equal to minus 35. Because of what we found, we know that the sum of the paired roots is equal to c over a, which is minus 35. So I'm going to take out a factor of 5 here. So minus 7 is equal to 2 alpha squared plus 8 alpha d plus 7d squared. And then I'm going to try and use my identity that that alpha plus 2d is equal to 1. So I'll say I know, and I'm going to rearrange this so I can get this as many times as possible. So minus 7 is equal to alpha times 2 alpha plus 8d. Now I can take out 2 times alpha plus 2d here, which will just be 2 alpha plus 4d, which will leave me with 4d's left. So I can replace this all with 2 plus 4d plus 7d squared out here. And so I get minus 7 is equal to 2 alpha plus 4 alpha d plus 7d squared. And what I can do now is I can take out a factor of d here and here. So that will give me 4 alpha plus 7d times d. And once again, I can take out 3 alpha plus 2d, which I know is just 1, plus alpha plus 3 times 2 is 6, so 7 minus 6 is 1, plus d. And so what I'll be left with is 3 plus alpha plus d. And that will give me minus 7 is equal to 2 alpha plus 3d plus d alpha plus d squared. And I can take one last alpha plus 2d out here, so that will leave me with 1 plus alpha plus d plus alpha d plus d squared. And that's equal to minus 7. And I can take this 1 over and subtract from both sides, so that will give me that it's all equal to minus 8. And what I'm going to do now is I'm going to form a quadratic equation in terms of d squared. So I can say that 0 is equal to d squared plus alpha plus 1 times d. So here's the 1 and here's the alpha, plus alpha plus 1 times d, plus alpha plus 8, and that all is equal to 0. So now I've got a quadratic in terms of d and alpha. So I know that d will be equal to negative b, negative alpha plus 1, plus or minus the square root of b squared, alpha plus 1 squared, minus 4 times alpha plus 8. 4 times a, which is 1, times c, which is alpha plus 8. And that will all be over 2a, which is just 2. Now I'm going to multiply d by 2. So I get 2d, and I'm going to add alpha to... I get 2d is equal to minus alpha minus 1 plus minus the square root of alpha plus 1 squared minus 4 alpha plus 32. That will be in a bracket. And the reason I'm doing this is I want another one of my alpha plus 2d, because I know that is equal to 1. So I'm going to add this alpha to both sides, and I get alpha plus 2d on the left side, which I know I can just replace with 1. But I also have a 1 here, a minus 1 here, so I can add that to both sides. So I'll draw an arrow across, and so I'll get that 2 is equal to plus or minus the square root of alpha plus 1 squared minus 4 alpha minus 32. And what I'm now going to do is I'm now going to square both sides, but I have to remember that I did have a plus and minus here, so I will be looking for two solutions later. So 4 is equal to alpha, I'm just expanding this bracket here, is equal to alpha squared plus 2 alpha plus 1 minus 4 alpha minus 32. So 4 is equal to alpha squared minus 2 alpha minus 31. Bring the 4 across, and that will give that 0 is equal to alpha squared minus 2 alpha minus 35. And I can now form another equation to solve for alpha. Or I can see if this will factorize. So two numbers that will add to make minus 2 and multiply to make 7. Sorry, minus 35, and that will be alpha minus 7 alpha plus 5, which gives me that alpha will be equal to 7 or alpha will be equal to minus 5. Now, which is it? It doesn't actually matter, because if alpha is equal to 7, then phi, because they're in an arithmetic progression, then phi will be equal to minus 5. Or if alpha is minus 5, then phi will be equal to 7. All that depends on is what d will be. So if alpha is equal to 7, or actually no, I'm going to do if alpha is equal to minus 5, and I know that gamma is equal to 2 alpha, no, so not 2 alpha, alpha plus 2d and is equal to 1, then I know that gamma is also equal to 2d minus 5, and that is equal to 1. So 2d is 6, therefore d is 3. If you do this the other way round with alpha as 7, you'll get that it is actually plus and minus, but we're just going to deal with plus 3. So the roots, alpha is minus 5, and we're just going to add 3 each time. Beta is minus 2, gamma is 1, delta is 4, and phi is 7. And that's our final answer. Thank you for attending this video, and I look forward to seeing you all next time.